Continuing on with our circles here, in your opener it says that AC is the diameter and BD is a radius with a length of 3 inches. So right away we know since BD is a radius with a length of 3, then DC, which is also, DA, which is also going to be a radius, will also be 3. So to go through and find AB then, I have a right triangle here that I can work with. 3, 3, there's my missing piece. So using Pythagorean theorem, we got x squared equals 3 squared plus 3 squared. And 3 squared is 9. So we have x squared equals 9 plus 9. So x squared is 18. When we take our square root of each side, we have x equals, I have the square root of 18. Now, if I want to put it as a big ugly decimal, we can, because the directions do not specify. Or we can look to break it down. A perfect square that goes into 18 was 9. 9 times what? And the answer is 2. We picked 9 because we know the square root of it. So that square root of 18 actually breaks down to 3 square roots of 2. Now, there's going to be a few properties that we go over today. Our first one says that if we have 2 chords in our circle, so we'll look at chord AB, and we will look at chord CD. If the 2 chords are congruent, so if AB and CD are congruent, then the arcs they make, this arc AB and this arc CD, they'll have to be congruent also. So arc AB is congruent to arc CD if and only if those 2 chords are congruent. So essentially saying that if our chords are congruent, then the arcs they make are going to be congruent. Taking a look at our example then. So in your diagram, circle A is congruent to circle D. Since chord BC is congruent to chord EF, that means the measure of arc EF will be congruent to the measure of arc BC. So since EF is 125 degrees, BC will also be 125 degrees. For our next idea, right, basically says that whenever you have a chord that is the perpendicular bisector of another chord. So here's my chord. If I'm going to be the perpendicular bisector of that, so I'm going to have to bisect that chord and be perpendicular to it. The only thing that could ever do that, the only thing that can ever bisect our chord and be perpendicular to it, will have to be the diameter of your circle. So this would have to go through the center of your circle. This is a segment that is the perpendicular bisector of a chord will have to be the diameter of your circle. Now, as it turns out then, the converse is also true. If you have your diameter and you're perpendicular to a chord, you will have to bisect that chord. And likewise, you're going to have to bisect that arc that is there. So when a diameter is perpendicular to a chord, it will bisect the chord and it will bisect the arc. Right? If you're following the notes, please do not worry about example 2. All right, we're gonna skip over that and I'll come back to it here. But taking a look at example 3 then. It says use the diagram of circle E to find the length of BD. And it says tell what theorem you'll use. So here we have the diameter AC being perpendicular to our chord. If you are perpendicular to your chord, you will bisect that chord. Since AC is the diameter, and it is perpendicular to BD, then BF and FD will have to be congruent. So BF will have to equal 6. Which means BD, which is our whole segment here. Oops. The top part 6, the bottom part 6, so BD will be 12. Bring us to our last theorem today. Goes back, and once again it talks about two chords being congruent here. If my two chords, AB and CD, are equal in length, the other thing that has to be true about them is they must be the same distance away from the center of your circle. Keep in mind, when we talk about the distance you are away from something, we are talking about that perpendicular distance. So if this is 3 inches, this length here is also 3 inches. So when your chords are congruent, they are equidistant from the center. So if chord AB is equal to chord CD, then that segment EF is congruent to EG in this picture. Taking a look at a few examples then. In our first one here, it says in your diagram of circle E, AB is equal to CD, which is equal to 12. Find the measurement of EF if the radius is 10. So since AB and CD, AB and CD are both 12. That means each of these small pieces are all 6. It wants us to find this segment here, EF, if the radius is 10. Well, there is no radius drawn in our picture yet. So we can draw one in anywhere we want. We can go E to D, we can go E to B, we can go E to C. However, the most convenient one will be going E to A, because now we have this right triangle here that we can now pull out. Pythagorean theorem then says that 10 squared will equal x squared plus 6 squared. So 100 equals x squared plus 36. Subtract our 36 over, we have 64 equals x squared. And then we will take the square root of each side. So we get x to equal 8. In our next example, it says if the measurement of arc TV is 121 degrees, find the measurement of arc RS. Since my chords are equal, the arcs they make will be equal. So since arc TV is 121 degrees, arc RS will also be 121 degrees. Right? Here it wants us to find the measurements of arc CB, BE, and CE. Once again, BD is our diameter. And it is perpendicular to your chord. If it is perpendicular to your chord, it will bisect the chord. And more importantly in this picture, it will bisect our arc that is there. So arc BC will have to be congruent to arc BE, which means that 4x will have to equal 80 minus x. We'll add x to both sides. We got 5x equals 80. We divide, we get x to equal 16. Now, if x is 16, they want us to plug it in and find the measures of our three arcs that they want. Arc CB would be 4 times 16, which would be 64. Arc BE would be 80 minus 16, which would also be 64. And arc CE, which is the whole thing there, would be those two arcs added together, 128. All right, taking a look at our last problem then. It says in your diagram in example 4, AB is 27, EF and GE are both 7. So EF is 7, GE is 7. If AB is 27, find the length of CD. Point G to E and F to E, those two chords are equidistant from the center. Since the chords are equidistant from the center, the two chords will have to be equal in length. So since AB is 27, CD will also be 27. All right, brings us to our homework here. Pages 667 to 668. All right, and we're going to have one more section here before we get to a 8-1 to 8-4 quiz. Oh, I'm sorry, 10-1 to 10-4 quiz. We'll talk about that here as class progresses. All right, if you have questions, please reach out and let me know. And we'll go from there. All right, have a good day, everyone.